Okay, this is the 2016 AP Calculus AB free response test. This is the actual test that was given. We'll start with number 1. It says water is pumped into a tank at a rate modeled by W of t is equal to 2000 e to the minus t squared over 20. So that's the rate it's pumped into, and it's removed from the tank based on this table of values. Okay, so at time t equals 0, there's 50,000 liters in the tank. So part A says to estimate R prime of 2, and you've got to show your work. All right, an estimate would be the slope of the secant line. And the values you would want to pick are the ones around 2, so from 3 to 1. Okay, so the slope is equal to the change in y over the change in x. So that's y2 minus y1 over x2 minus x1. All right, that'd be 950 minus 1190. You do get your calculator on this part, by the way. Over 3 minus 1. Those are the two values that surround 2. All right, and that's minus 120 liters per hour squared. Now, how do you get the proper units? And you will need to have the proper units. It's liters per hour per hour. Okay, the unit for the y value, R of t, divided by the unit for the x value, which is time. So liters per hour per hour. So that'd be liters per hour squared. So that's your estimate of R of 2. All right, part B says use a left Riemann sum with 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is it an overestimate or an underestimate? And give the reason for your answer. Okay, well, a left Riemann sum we're going to use, so we're going to divide this table into 4 subintervals, so 4 rectangles. I'll do that in blue. That rectangle, that rectangle, that rectangle, and that rectangle. So for our first rectangle, the base, because t is the x value, R of t would be the y value. The base is 1, and the left height is 1340. For the second rectangle, the base is 2 from 1 to 3. The left height is 1190. For the third rectangle, the base is 3. The left height is 950. And for the fourth rectangle, the base is 2 from 6 to 8. And the left height is 740. So, you know, you get to use your calculator, thank goodness, but that's 8,050 liters. Now, this is going to be an overestimate because this is a falling function. All right, 1340, 1190, 950, 740, 700. If you were to graph this, it would look like that. Okay, so a left Riemann sum always overestimates a falling function. You've got that excess material in that rectangle. Okay, so if you use the left height, so your explanation is a left Riemann sum overestimates a decreasing function. So the answer they're looking for, and they want the, you know, that's what they're looking for, overestimates. And if a left Riemann sum would underestimate, if this function were rising, then it would underestimate it. You know, if it were going like that, okay, your left sum, you'd have some material not accounted for underneath, right? Like that. Okay, so in this case, if we had done a right Riemann sum, it would underestimate. Okay, so something worth, it's kind of something worth memorizing, thinking about. All right, part C says use your answer from part B to find the estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. Okay, I think I can fit that down here. So we start with 50,000. Then how much got pumped in? Well, that's going to be from 0 to 8 of W of T dt. So I'm not going to write all that out, but you put that in your calculator. And then you want to subtract out this 8,050 right here that got removed from the tank. Okay, so when you put that number in your calculator, go ahead and try that. You should get 7836.195. So 50,000 plus 7836 minus 8,050 is 49786.2 liters. All right. Okay, so that is part C. I'm going to have to erase, so pause the video if you need to, and we'll work on part D. Okay, part D says for time between 0 and 8, is there a time t when the rate at which the water is pumped into the tank is the same as the rate the water is removed from the tank? Well, you could graph this and you can see that it's a falling function. So what it's asking is somewhere between between time 0 and time 8 is W of t equal to R of t. Okay, and you just need to know, are those two lines going to cross somewhere? Okay, well, first of all, let's figure out W of 0. All right, well, that's going to be, if you plug 0 in for t there, that's just going to be 2,000. And R of 0, according to the table, is 1340. And then let's take a look at time 8. W of 8, plug in 8 there, you get 81.52. And R of 8, you can look right at the table, is 700. So if we were to plot this, okay, W of 0 at time 0, we'd have 2,000. And at time 8, we're all the way down to like 81. For R of 0 is 1340, so let's put that like right here. And then R of 8 is 700. Well, let's put that like right there. So somewhere they have to cross, right? As long as they're continuous. Okay, so the what you want to write is something like this. Since W of 0 is greater than R of 0, and W of 8 is less than R of 8, the intermediate value theorem, that's what they're looking for. States that at some value, so if it's continuous, they have to cross, right? At some value between 0 and 8, R of t has to equal W of t. So they're looking for that intermediate value theorem somewhere in the explanation. All right, that's number 1. Turn on over to number 2 and pause the video if you need to. Tell you what, you might want to fast forward through some of it. Number 2. So number 2 says the velocity of a particle is given by v of t is equal to 1 plus 2 sine t squared over 2. And the particle is at position x equals 2 when time is equal to 4. So part A says, at what time t equals 4 is the at time t equals 4 is the particle speeding up or slowing down? All right, what we need to do is figure out what's the velocity at 4 and what's the acceleration at 4. If they have the same sign, they're speeding up. If they have opposite signs, they're slowing down, just like we learned in physics. Okay, so first of all, let's get v of 4. You're just going to plug 4 into t right there. Your calculator will say that's 2.978. Now we also have to get the acceleration function. So that's going to be, take the derivative of the velocity. And if you take the derivative of the velocity, all right, it's going to be derivative of sine is cosine. So a derivative of 1 is 0, so it's going to be 2 cosine t squared over 2 times, okay, the derivative of t squared over 2 is just going to be t. All right, so plug in 4 into that, plug in 4 there, and 4 there into t, and you will get an acceleration of negative 1.164. So the answer is slowing down because A of 4 and V of 4 have opposite signs. Okay, so that kind of reminds you of physics chapter 1. Okay, that is part A. I think I can fit part B on this board. All right, part B says find all times t in the interval between 0 and 3 when the particle changes direction. Okay, so what you need to do is graph v of t. Okay, so I'm going to try to do that and see if I can Okay, I've already typed it in here. All right. Typed it in, and I'm going to hit F2 and, all right, I don't know if you can see that, F2, 2. Okay, so we want to know where it changes direction between 0 and 3. And if you'll look at your target, where the velocity crosses the x-axis, that's where it changes direction. So it does it at about 2.7 or so. And then the next time it crosses the x-axis is greater than 3. So we're only worried about this point. All right, so how are you going to figure out exactly? All right, well, you want to go to F5 and then hit 0. So that's the second option. Your lower bound, do somewhere above the x-axis, just hit that. And then the upper bound, go below the x-axis and hit that. And it'll give you where it crosses the 0 at 2. Let's see if you can see that, 2.707. Okay, so in case you couldn't really see that, the answer is 2.707. But I'll go ahead and give you, so you want to graph and then zoom, hit F5, 0, and then do your lower bound and upper bound on either side of the 0, and it'll give you the exact value. Okay, so to justify, you do have to write a justification. Just write V of t changes from positive to negative. At t equals 2.707. So that should be enough justification. All right. Let's look at part C. Part C says, find the position of the particle at time t equals 0. Okay, so first of all, we have to get the position function, s of t. And we know that that is, we're going to have to integrate v of t. Okay, so we know that the initial position, or the initial condition, x is equal to 2 and t is equal to 4. So if we want to know the position at when t is 0, x of 0, okay, so I guess I would use probably x of t maybe here instead of s. But x of 0 is going to be the initial condition, x of 4, plus what you do is you integrate from where you start, 4, to 0 of v of t dt. And you want to use your calculator on this part. Now your calculator can handle the starting at the bigger one and going to the smaller one. Okay, well, we're at 4 and we're going backwards to 0. We know that x of 4 is equal to 2. Okay, at time t equals 4. So if you put this part in your calculator, I want you to try that, you'll get negative 5.815. So the position at times 0 is negative 3.815. All right, star this one. This is one worth looking at. Okay, so you know you have to, this is a little different. You have to start at the initial position and go to where you're trying to get at 0. But your calculator will do all the work for you. Okay, and then part D says find the total distance the particle travels from time t equals 0 to time t equals 3. All right, that total distance, you integrate. Remember, we're totaling up something, so we're going to integrate from 0 to 3, the absolute value. Okay, you want to go in your calculator to catalog, and then it's one of the first options, ABS. Because it's moving back and forth, so if we just do 0 to 3, it's gonna add and subtract and add and subtract, okay? If you do the absolute value, it'll take all those negative numbers and make them positive and give us the total distance. Give that a try and see if you can get 5.301. Okay, the next number I have to draw the graph out, so I'm gonna, since that'll take some time, I don't wanna waste your time. We'll stop the video here and we'll pick up at number 3 on the next video.